Hello, good morning, student. Today I'm going to discuss with you this property 7, that is proof that gradient of a bar dot b bar is equal to b bar dot del into a bar plus a bar dot del into b bar plus b bar cross curl of a bar plus a bar cross curl of b bar. So I think the notes you must have copied. So let me explain each step. So proof we have the left hand side is equal to, by gradient we mean del, the operator del operate on this vector scalar product of these two vectors, and you just replace del here by I del del x plus j del del y plus k del del z of a bar dot b bar. Now apply this I del del x on a bar dot b bar plus j bar dot into del del y of a bar dot b bar plus k cap del del z of a bar dot b bar, which is equal to I into, apply for this, you operate first this del del x on b bar, keeping a bar as constant. What we have is I cap into a bar dot del b bar del x plus del a bar del x dot b bar. Similarly with j also the same thing, you operate on b bar this del del y, you have j bar into a bar dot del b bar del y plus del a bar del y dot del z. That's why in the notes they have written it as summation, because that summation stands for the sum of all these three. That is the operator, when you apply this operator del del x del del y and del del z on a bar dot b bar. So now you take this plus this. So you have I into a bar dot del b bar del x plus j into a bar dot del b bar del y plus k into a bar dot del b bar del z. Now plus this again, del a bar del x in dot b bar, you apply it on I plus b bar dot del a bar del y, because this is a scalar quantity. So if you apply this I on any, either from the front part or from after this operator also, it will be the same only. So you have b bar dot del a bar del y into j plus b bar dot del a bar del z into k bar. So we name it as equation 1. But we know that from the cross product of three vectors, a bar cross b bar cross c bar is same as a bar dot c bar into b bar minus a bar dot b bar into c bar. So bring this to this side. So this implies that a bar dot this one, a bar dot, bring this to this side. So what remains here is a bar dot b bar into c bar. Bring this to the other side. So you have a bar dot c bar into b bar minus this, that is a bar cross b bar cross c bar. So you replace this vector a bar here. You replace this vector a bar by vector a bar here, and then this del b bar del x you replace for this vector b bar, and c you replace it by I. So therefore, similarly for this also, you replace this a by this vector a bar here by small capital A bar, and this as del b bar del y, and this as j cap. Similarly with k also. So what we have is, let me just show you this first part only, the rest will follow from this. You just replace I and j by I, or I by j, I again by k. So you have a bar dot del b bar, a bar dot I cap into del, by applying this result. So you have a bar dot I cap into del b bar del x minus a bar cross del b bar del x cross I. But we know that in a vector, in a cross product, a cross b bar is same as minus of b bar cross a bar. So if I want to remove this minus, so I'll have to replace this. I'll write del b bar del x cross I as I cap cross del b bar del x. So this minus will change to plus using this result. So therefore we have a bar okay, dot I into del b bar del x plus a bar cross I cap. Instead of this, I'll replace it by I, write this. So we have plus here, I cross del b bar del x. Now substitute this value here. Similarly for j also, you replace this I by j and x by y. Wherever I and x are there, you replace it by j and y respectively. And for k also, you replace it. So therefore, this first three part, the sum of this is equal to this. So since I haven't changed this this cross product, so I give it as minus sign here. So in the next step, I'll replace it by I cross del b bar del x so that this will become plus. So for similarly with the second term also, you replace it by this b bar by vector a bar and del a bar del b del x as vector b bar and this I as c. So wherever j and k are there, you replace I by j and j by k. So you have the same thing now. So since I have replaced that minus, now I want to express this as del b bar I cross del b bar del x. So this will become plus, this also become plus. So the next second part also will become plus. So we have a bar dot I into del b bar del x plus the a bar cross I cross del b bar del x plus. Similarly, the rest will follow as it is by using that cross product of three vectors, that formula. So we have here now, see, take out this first part and then this with this. So what do we get is a bar dot I into del x, because they operate on b only, this. So you take these three vectors together. So a bar dot I into del x plus j cap into del y plus k cap into del set of vector b bar plus a cross. Here also the same thing, a cross, you take it with this with this. So you have a bar cross. You have a bar cross of I cross. Yeah, I cross del b bar del x, this b, because it operates on b, so you write it outside this bracket, so operator b bar. Similarly with the second term also with b bar, the same thing only, you just replace b by a and del b bar del a bar del b bar del x del b bar del y and del b bar del z by del a bar del x del a bar del z and so on. So what we have here, let us just look at the first term here. It is, this operator is nothing but del, so you have a bar dot del on vector b bar plus a cross. Here this operator here is nothing but del cross vector b bar, but the cross product is already there, so you have a cross of del cross b bar plus. Similarly with the second terms, in terms of b also, you just replace b a by b and del a b bar del x by del a bar del x and so on. So you'll have b bar dot del on operator a bar plus, not on a bar plus b bar cross del a cross bar. So therefore you write first this plus, but this del cross b is nothing but curl of vector b bar. So you have a bar is equal to a bar cross, this one is curl of vector b bar, so you have a bar cross curl of b bar plus b bar del cross vector a bar is curl of vector a bar. So this proves that the gradient of a bar dot b bar is equal to this value. Next we come to number 8. Proof that divergence of gradient of phi here is equal to del 2 of phi. That is del dot del phi is equal to del square of phi. So as you know, del dot del phi is nothing but del phi del x into I plus del phi del y into j plus del phi del z into k. But you operate this del, so you have I del x plus j del y plus k del z dot of del phi. That is del phi is this. Now I dot I gives you 1, so del x of del phi del x is nothing but del 2 phi del x2. Now I dot j gives you 0, I dot k also gives you 0, so you have here. Now you operate j on this also will be 0, but j dot j gives you 1, so you have del y into del phi del y, that is del 2 phi del y2. Similarly with del 2 phi del z2. Now you can remove this is same as del 2 del x2 plus del 2, because they operate on phi only, scalar function phi. So you have del 2 del x2 plus del 2 del y2 plus del 2 del z2 on phi is equal to, but this is nothing but del square phi, that is the Laplace operator I have explained to you just after the definition of irrotational and solenoidal vector. So this complete their proof. Now number 9 is this. Proof that curl of gradient of phi is equal to 0 vector, or you can say that del cross del phi is equal to 0 vector. As we know that gradient of phi, that is del phi, stands for I del phi del x plus j del phi del y plus k del phi del z. So curl of gradient of phi is del cross del phi, and we know that using this this cross product, that is curl of using determinant rule, del here stands for I del x plus j del y plus k del z cross of del phi, now which can be written and replace this del phi also by this value here, that is I del phi del x. Express it, this is the cross, there is cross here, so you use determinant rule, where the first row you express it as the component I j k, and the second row you take the component of I here, that is del x, component of j here it is del y, component of k is del z. Now take the component of I j k from the second operator, that is del phi, that is del phi del x, component of j it is del phi del y, and component of k here it is del phi del z. Now apply determinant rule here is I into del y of del phi del z. So del y of del phi del z is nothing but del 2 phi del y del z minus del z of del phi del y, that is del 2 phi del z del y, into I cap plus j here, this operate on this minus this on this. But as you see that we assume here that phi has a continuous second order partial derivative, so therefore this del 2 phi del y del z is same as del 2 phi del z del y. So therefore this will get cancelled, because this and this will get cancelled because they are the same, since we assume phi is has a continuous second order partial derivatives. So therefore this whole thing becomes 0i plus 0i plus 0j, because this also the same thing, this is same as this, so therefore this will become 0. Here also it will become 0, so you have 0i plus 0j plus 0k cap, which is equal to 0 vectors. That is curl of gradient of phi is equal to 0 vector.